battery management system in electric vehicle. Myself, Indhumathi, Assistant Professor, Department of Electrical and Electronics Engineering, PSN College of Engineering and Technology, Tirunelveli. So the battery management system, BMS, that is very important in electric vehicle, because of the battery is the heart of the electric vehicle. Likewise, engine vehicle, the IC engine is the heart of the vehicle. That same principle, the battery is the heart of the vehicle in an electric vehicle. So the battery management system is very important in electric vehicle. Let's see about the BMS. So now we discussed about these points. What are the battery basics, introductions, and why we need BMS, general function of BMS, and block diagram, and BMS architecture, battery pack, voltage, current, temperature, and isolation sensing, high voltage contactor control, and BMS communication interface, estimation of energy and power, and SOC, method to find SOC. SOC means state of charge. Cell balancing, relationship between SOC and DOD, depth of discharge, and conclusion. So these points cover all those things in BMS. Okay. So initially we see them difference between cell, module, and pack. So the cell, that means battery cell. The single cell is the battery cell. That is I mentioned the unit of your battery that exerts electrical energy by charging and discharging, made by inserting anode, cathode, separator, and electrolyte in an aluminum case. So this is called a battery cell. And battery module, so connecting number of cells in parallel or series, is called a battery module. And battery pack, the battery modules are connected in series and parallel. So these are the difference between the battery cell, battery module, and battery pack. Now let's see the battery structure. So the battery structure means individual cell. I already told the individual cell is the battery cell. The first one is battery cell. The A and the B, the both diagram show the individual cell, and parallel series combination. So we connected a cell in a parallel or series mode. That is name is called parallel or series connection. And pack, the battery pack. The battery pack means the modules. That means one rows are connected in parallel or series, and 5 rows are connected in series or parallel. That is the battery pack. Each row is module, and 5 rows are, I said one example, the 5 rows are pack. Okay. Now difference between the lithium and other batteries. Because of the lithium is the, nowadays we mostly use the lithium ion battery. In previous day we used so many batteries, that is lead acid batteries and nickel based batteries, and now we used lithium based battery. Why we moved to lithium based battery means lead based battery cell is each individual cell voltage is 2.1 volt, but in lithium cell means 3.8 volt, and nickel 1.2 volt. That's why we moved to lithium based cell. We getting 3.8 voltage from the cell. And type of lithium batteries, we have so many lithium batteries are there. So the first one is lithium cobalt oxide, and lithium manganese oxide, and lithium nickel manganese cobalt oxide, and lithium iron phosphate, and lithium nickel cobalt aluminum oxide, and lithium titanate oxide. So these are all the batteries types in the lithium category. So the NMC batteries, nowadays NMC batteries are used in Tesla cars. So these are all good, but some advantages and disadvantages having this batteries compared to other things. And C rate. So the charge rate is very important in all the batteries. It may be a lithium or it may be a lead acid. The charge rate is very important. So that is battery current handling capacity, and it is a constant current charge or discharge rate which the battery can sustain for 1 hour. So for example 12 volt 20 hours battery 12 volt 20 volt, I take a 12 volt 20 volt battery, 20 ampere hour, it can be delivered 1 hour for a 2 amps for 10 hours. Okay, so if it is the battery is 1C rate, the battery will fully charge is take time means 1 hour. If it is 2C, 30 minutes. If it is 3C, 15 minutes. If it is 0.5C, 2 hours. 10 amperes for 2 hours. So we achieved 20 ampere. And 0.1C, 2 ampere for 10 hours. But we achieved 20 ampere. So these are all the difference between the charge rate. But the charge rate is also important in this the battery BMS system. And next, cell format of lithium battery. Because of the cell format is very important to choose the battery. So we have a 3 types. So the one is cylindrical, prismatic and pouch. So mostly we use a cylindrical cell in laptop or in mobile phone or any drone. The cylindrical cell because of it is a compact size. But prismatic, in the case of prismatic, the most of the electric vehicles are used as prismatic, the large size and hard casing. But the cylindrical cell is small size. Example, it is a 80 mm and height 650 mm, and hard casing, low individual cell capacity and built-in safety feature comparatively cheap. Cylindrical cell. If it is pouch cell means soft casing, large size, high individual cell capacity and geometrical deformation during discharge. So these are all the comparison between the cylindrical and prismatic and pouch cell. So now we are coming to the point, the BMS. So in electric vehicle, generally it contains following major components. So that is electric motor, motor controller and traction battery and battery management system and wiring system, vehicle body of frame, etc. These are the major components. The battery management system is one of the most important components, especially when you are using a lithium battery. I mentioned the lithium battery. The lithium cell operating voltage, current and temperature must be maintained safe operation area. That is mean a SOE at all time. That's why we move to lithium cell. Okay. To maintain the safe operation of this battery, they require productive device to build into each pack is called battery management system. So we maintain safe operation. That's a very important point. The safety is very important for all the people. So the BMS make decisions on charge and discharge rates on the basis of load demand, cell voltage, current, temperature measurement and estimate of battery SOC, capacity, impedance, etc. The BMS is a part of complex and fast acting power management system. So then why the BMS is coming to the vehicle? That's a history. On 7th January 2013, a Boeing 787 flight was parked for maintenance. During that time, mechanical noticed flame and smoke coming from the auxiliary power unit. So the auxiliary power unit means they use the lithium battery pack of the flight. On 16th January 2000, another battery failure occurred. 787 flight operated by all Nippon Airways, which caused emergency landing at the Japanese airport. So the battery is now failed. After a series of joint investigation by US and Japanese, lithium battery pack B787 went through CT scan and relevant that one of the 8 lithium ions are damaged, causing short circuit, which triggered a thermal runaway with fire. Because of the thermal, it make fire. This incident could be easily avoided if the battery management system of the lithium ion battery pack was designed to prevent short circuit. So that's why we implement a BMS. And why we need BMS means detect unsafe operating condition and respond. Very important, right? And protect cell of battery from the damage in abuse and failure cause, and prolong life of battery, maintain battery in a state. So the function means it sends and high voltage control, measure voltage, current, temperature and control contactor, pre-charge, ground fault detection, thermal management. And production, overcharge, over discharge, overcurrent, short circuit, extreme temperature. We have generally the lithium battery bag inbuilt BMS. These are all the points. Interface, range estimation, communications, data recording and reporting. And performance management, state of charges, OC estimation, power limited computation, balance and equalize cell. And diagnostic, abuse detection, state of health estimation, state of life estimation. So these are the battery pack diagram. So now the input is the battery pack, right? Now we give the voltage, current and temperature by using some sensors. Measure. From the measuring device, we used capability of estimation of state of charge, state of health and management with the help of CAN bus controller. With the help of controller, it may be a Arduino, it may be a ESP232, it may be a Raspberry Pi. So these are all the block diagram of the what? BMS. Now the BMS architecture. The module battery pack suggests a hierarchical master slave BMS. There is normally a single master unit of each pack. That is a master BMS, slave BMS and slave BMS, slave BMS. And BMS master role. Control contactor that connect battery to the load so that it control. Monitor pack current isolation. Communicate with BMS slaves, control thermal management. Communicate with host application controller. And BMS slave role. Measure voltage of every cell within a module. So that's why measure temperature. And it is also balance the energy stored in every cell with the module, communicate this information to the master. Then battery pack voltage sensing. With the help of some sensors, voltage sensor, we sense the voltage and it will be displayed in any device. That means the IoT. Why we consider cell voltage? Indicator of relative balance of cell, input to most SOC and SOH estimation algorithm, safety, overcharging a lithium ion cell can lead to thermal runaway. So we cannot skip measuring any voltage. Voltage is measured by using analog to digital converter. Yeah, the direct conversion of flash ADC and successive approximation delta sigma. Special chipset are made to aid high voltage BMS design. Multiple vendor and make chipset. Example analog device, Maxim, Texas Instrument. Then battery pack. So the battery pack current sensing. How it is sense the current? The same as that of the voltage, but it is connected to series. To monitor battery pack safety, to log abuse condition by most state of charge and state of health algorithm using a shunt and using a Hall effect mechanism. Next, battery pack temperature sensing. So it is very important. Temperature sensing is very important to save the battery. Battery cell operational characteristics and cell degradations rate on very strong function of temperature. Yeah. Unexpected temperature changes can indicate cell failures or impending safety concern. So that's why we measure the temperature. There are two methods, using thermocouple or using thermistor. Thermistor has two types. Negative temperature coefficient thermistor and positive temperature coefficient thermistor. So using both device, we measure the temperature from the battery, and if we need to display in any device, we use Arduino or ESP232 or Raspberry Pi. That is the CAN. And isolation sensing. So it detects the presence of ground fault. It may be ground fault. In a vehicle application, we must measure isolation between high voltage battery pack and chasing of the vehicle. So FM VSS says isolation is sufficient if less than 2 milliamps of current will flow when connecting chases ground to either the positive or negative terminal of the battery pack via direct short. Then contactor control, high voltage contactor control. These are the diagram of the high voltage contactor control after the battery, before the controller. So disconnecting or connecting battery pack at both terminals require high current capable relays or contactor. A low voltage or low current signal activate the contactor, closing an internal switch and connect the main terminal. If both conductors are very close simultaneously, enormous current would flow instantly and blowing a fuse. So a third pre-charge conductor is used. Because of the charge controller, it may be, suppose sometimes it leads to high voltage. So we use a high voltage conductor control. If it is the high voltage happened, the conductor is what? Removed. Then it will save to the drive, save to the vehicle or save to the battery. So the BMS communication interface, that is control area network, is industry ISO standard for onboard vehicle communications. That is two-wire serial bus designed to network intelligent sensors and actuators can operate in two rates: high speed, low speed. The high speed means it is used for critical operations such as engine management, vehicle stability and motion control. If it is low speed, simple switching and control of lighting, windows mirror, adjustment and instrument display, etc. Okay, onboard vehicle communication. So LIN bus is another automotive communication standard similar to the CAN bus. It is a single wire local interconnect network operating at 20K bound with low cost IC solutions. The FlexRay bus can support fast responding dynamic control system rather than just the simpler sensors and actuator permitted with a CAN bus. The FlexRay payload by frame is 20 minutes greater than CAN bus. So continues of the previous slide, the integrated circuit 12C bus was a low speed bus originally designed for use between an internal module with the system rather than external communication. So these are all communication interface for the component communication, right? Component communication in the vehicle, not for human communication or component communication. It is a bidirectional half duplex two-wire synchronous bus. It runs with data rates up to 3.4 Mbps and it's suitable for master-slave applications. Multiple slaves are possible, but only a master can intermediate data transfer, typically used for internal communications within embedded systems such as BMS. The ASM bus is a two-wire 100 kHz serial bus designed for use with a low power smart battery system with a limited objective of the interconnecting smart batteries with have built-in intelligent with associated charger. So many buses are there. These are all for communicating the components in series mode or parallel mode to ensure the safety. So that's why we used it, or to ensure consume the power, low consume of power. Then estimation of energy and power. So coming to the power point, we consume so many power because of we measure voltage, current, temperature, and if it is the high temperatures happen, we need to cool the battery. So we need to some setup for cool down the battery. That's why we consume some power. That is we calculate. Cannot directly measure the available energy or available power. Therefore, must estimate SOC, SOH. To estimate energy, we must know all cell state of charge and charge capacity. To estimate power, we must know all cell state of charge and resistance. So that is voltage, current, temperature, and state of charge, charge capacitance, charge resistance, and charge reactance. From this components and from these elements, we ready to find the energy and power consumption of the battery. So the available inputs include all cell voltage, pack, current and temperature of the cell module. How to find the state of charge? So the state of charge of a battery is defined as the ratio of its current capacity to the nominal capacity. The nominal capacity is given by the manufacturer and represents the maximum amount of charge that can store in the battery. The SOC can define as follows. The formula of SOC, the capacity of current capacity and minimal capacity. The SOC changes only due to passage of current, either charging or discharging the cell due to external circuitry or due to self-discharge within the cell. So this is the way to find the state of charge. And now, why the state of charge is important? Because of, I already told, if it is a state of charge has happened, then we have to, then only we are able to find the energy or power. So why SOC is important means prevent overcharge or discharge, improve the battery life, protect battery, improve the battery performance, and for cell balancing application, it's only necessary to know the SOC of any cell related to the other cell in the battery chain. Okay. So then, method to find the SOC. There are 4 methods: direct methods, bookkeeping estimation, adaptive system, and hybrid system. So direct method means this method uses physical battery properties such as voltage and impedance of the battery. This way to find the SOC. And bookkeeping estimation, this method uses discharging current and input and integrate the discharging current over time to calculate the SOC. An adaptive system. The adaptive system are self-designing and automatically adjust the SOC for different discharge condition. Yeah. In hybrid method, combining 2 methods, hybrid model of form a hybrid model of each SOC system. So the 2 method means the above of any of 2 method. So continuous of previous session. So the first we see the direct measurement, open circuit voltage method, terminal voltage method, and impedance method. There are 3 methods, and impedance spectrography methods. So these are all the direct measurement method to find the SOC. And bookkeeping estimation means these are the formula. Coulomb counting method, that means a charge, and modified Coulomb counting method. This is a charge variation in the initial or now running and now ending, how the variation between the charges in the battery. Now find the SOC. Next, adaptive. The neural network, RBF neural network, support vector, machine fuzzy neural network, and Kalman filter. So these are all the algorithm to find the SOC. These are all the embedded system. And hybrid system, Coulomb counting and EMF combination, Coulomb counting and Kalman filter combination, and embedded system EKF combination. So these are the combination of this neural algorithm and the charging counting method to find the method of SOC. Then cell balancing. The cell balancing is very, very important, because if it is thermal stresses happen in cell one cell, the particular cell is transfer the thermal to nearby cell. This is very important. Then only we maintain the cell balancing. So that's why I mentioned cell balancing scheme to prevent individual cells from becoming overstressed. Yeah, I told. The system monitors the voltage across each cell in the chain. So these are all have some types. The first one is active cell balancing method. This method is remove charge from one or more high cell and deliver charge to one or more low cell. Okay, first charge. And dissipative technique, find the cell which highest charge in the back, indicate by the highest cell voltage, and remove excess energy through the bypass resistor until the voltage or charge matches the voltage on the weaker cell is known as passive balancing. Charge limiting is a crude way of protecting the battery from the effect of cell imbalance is to simply switch off the charge. When the first cell reaches the voltage, the represent is fully charged state, 4.2 volt of our most lithium cell, and disconnect the battery when the lowest cell voltage reaches its cutoff point 2 volt during discharge. Then cell balancing. Lossless balancing is a superior way of cell balancing by means of software control. Yeah, it is happened. It is
must happen by software. All of this balancing technique depends on being able to determine the state of charge of individual cell in the chain. Some more precious method use Coulomb counting and take account of the element temperature and the age of the cell is a cell voltage. So now what is the relationship between SOC and DOD? SOC means state of charge and depth of discharge. The depth of discharge means fully drained battery. Indicate percent which has been discharged related to overall capacity of the battery. So it compare the capacity of the battery. So the depth of discharge is the fraction of percentage of capacity which has been removed from the fully charged battery. Conversely, the state of charge is a fraction or percentage of the capacity is still available in the battery. A battery is at 100% SOC at 0% DOD. A battery is 80% SOC at 20% DOD. It is a mandatory for all the vehicle battery. Okay, 80% is limit of SOC, state of charge, and 20% of DOD. The conclusion of the BMS is the battery or the core energy source of EV and hybrid EV. Their performance greatly impact the stability of EV. Therefore, manufacturers seeking the breakthrough in both battery technology and BMS. The major concern of BMS are discussed in this presentation. Due to varying situation, in real world application, a standard solution was not wanted. Based on specific situation, different strategies should be applied to improve the optimized performance of BMS in future EV and HEV. So, thank you for the listening.